Hi, welcome back. In this video, we will be discussing about prime number. So before we go to the prime number program, let us understand what is a prime number. A prime number is a number that can be divided by itself and one. Okay. So let us consider a number. Let's say a number is 6, right? So this number uh, is said it will be a prime number if it is only be divisible by 1 and 6. Okay. So 1 and 6, right? Now if you see for the sixth number, if you start dividing this number 6 from any number in between 6 to 1 to 6, that is 2 3 2 3 4 5. Okay, so 2 3 4 5, we see that it is divisible by 2 also, it is divisible by 3 also. That means 6 is not a prime number. Okay, so let us consider another number. Right, let us consider another number. So number is equal to say 7. Okay, so if it will be a prime number if it is only divisible by 1 and 7. Okay, let us consider whether uh, the number between 1 to 7. Okay, one number 1 to 7 is 2 3 4 5 6. Okay, so whether this number divides 7 or not. So if you divide 7 by 2, will get a remainder 1. If you divide 7 3 by 7, also you'll get a remainder 1. If you divide 7 by 4, you'll get a remainder 3. If you get 7 divided by 5, you'll get a remainder 2. If you get divides 7 divided by 6, also will get remainder 1. So it is not divisible, neither 2 divide 7, nor 3 divide, nor 4, nor 5, nor 6. Okay, so as a result we only have two, uh, uh, only it is only 7 is divided by 1 and 7, so only two divisors. Okay, so that's the reason why 7 is a prime number, because the definition said a prime number is a number that can be only be divided by itself and 1. So 7 itself divide, okay, and only 1. Other 2 3 4 5 6 are not divisible, we have already seen. Now how are you going to design the entire logic itself, right? So as per the definition, what is said that it should be divisible only by 1 and 7. But we have seen that even the number is not prime, like 6 also, it is also divided by 1 and itself. Okay, so only the basic difference we find out is that if we want to see any number in between from 1 to the number itself and check whether it is divisible, it can divide or not, then we can find out easily the prime number, whether a number is prime or not. Say like for any number, okay, 6 or any number 7. Okay, so we are trying to find out whether any number between 1 to 6, that is 2 3, okay, 2 3 4 5. Okay, so 2 3 4 5. Okay, whether it is dividing 6 or not. So we found that 2 has 2 divides. Okay, then we said this is nothing but or not a prime number. Okay, but for 7 we see that 2 3 4 5 6 7, 2 3 4 5 6, it doesn't divide. So what we're going to do is we just need to find out, okay, right, for starting from not from 1, okay, starting from 2, 2 n minus 1. Okay, where n is the post for the number n, for the number n. Yes, for the number n, to check whether it is a prime or not. Okay, we start dividing the number from 2 to n minus 1. Okay, now if this is n is 2 itself, okay, if n is 2 itself, we have only two divisors, 1 and 2. So then we know that n 2 is also a prime number. Okay, so before n will be checking out also that n should not be, okay, n should not be, what is happening here? Okay, and okay, okay, and oh sorry, where? okay, right, and not equal to 2. Okay, if n is not equal to 2, right, we ahead with this particular concept, right, from 2 to n minus 1. Okay, whatever, because we are not checking 1, it is already divisible, and a number itself is already divisible. So we are trying to find out all the numbers between, okay, 1 to n minus 1, whether it is divisible, whether number divide or not. Okay, so now after that we can have a logic something like that. If an mod of I equal to 0, okay, right, that means it get divided, it is it is divisible, right? So that means it is only, it is a prime number, so it's not a prime number, so I can write not prime, okay, right, and I can simply, you know come out using the break statement, okay, right. uh, Now how will you come to know whether the number is prime or not? We will come to know whether the prime number is prime to note if it execute the complete, this loop till n minus 1, and we see that, we do not find any kind of division, right? So after that, if once the for loop will be completed, in this particular, the I value will be at last will be equal to n, okay. So that means we can write if I equal to n, yes, we can say it is prime. Okay, so let me again tell you what is a prime number. Prime number is a number which can be divisible by itself and 1. Okay, it can be divisible. Let us consider a number, suppose say 6. Okay, so 6 will be prime number if it is only divisible by 1 in itself. Okay, so but we want to see that other numbers in between 1 to 6 doesn't divide 6, but we know, but we have come to know that 2 and 3, okay, divides this number, okay, right, divide number 6. Then similarly, if I want to have 7, then we know that 2, 3, 4, 5, 6 doesn't divide, number 7. And then means number 7 will be having only 1 and 7, which is divisible. So number 7 is a prime number. Now, for this concept of using we don't divide by 1 and numbers we cannot do, because for prime number and not prime number we have the same set, right? So what we are doing is we trying to find out this logic, any number starting from less than more than starting from more than 1 and less than, less than the number itself. So let us consider number n. So it will not start from 1, it will start from 2 to n minus 1, and we're going to check in between this number whether it is divisible or not. Okay, if it is divisible, then we say it is not prime and will break out. Okay, now this loop will continue, okay, and see till it will go till n minus 1, and once it reaches n, okay, it will come out. So that's the reason why I said that at the time of when this loop will be coming out, the condition will be false, I value will be equal to n. So if I value is equal to n, means you have completed check, that is no divisible or there, so we write this is a prime number. Okay, so look, let's go back. So let us take a number int num, okay, and int I, okay, then printf, okay, enter the number, yes, I put scanf, right, percentage d ampersand num number, okay, right, if num equal to 2, if num equal to 2, printf prime number, yes, right, we write printf prime number, okay, yes, and okay, and we exit from the well, okay, otherwise I will simply write for I equal to 2, I less than minus 1, okay, I plus, oh, sorry, right? So we'll write here simple. What is that? If it is any of num minus 1, okay, if num divided by I equal to 0, okay, printf not prime, not prime, and brek break, okay, right? And then I write if I equal to n num, then printf prime number, okay, yes, right? So let me save it, let me execute. Okay, so we need to put a header file which is include process.h. Okay, let me save it, run. So let us put a number. So first two, prime number, very good. So it is, this statement has executed. Okay, so exit 0 means it will exit, come out of this program. Okay, now let us see 3. Oh, what happened? Why the output has not come? Okay, so we are not getting the output for 3. So let me see. Okay, so see, I said we have mentioned num minus 1. It should go till num minus 1. Okay, right? That means I should write here either equal to num minus 1, that is, or I can put just less than num. Okay, so that's a mistake I have done. So I'm saving it. Again, execute. So 3, yes, prime number. Okay, so let me execute what will be the output for 6. Not a prime number. Okay, let me see for 31, prime number. Okay, so let me again revisit. So I want to find whether a number is prime or not. Okay, so in order to find out whether a number of prime or not, we know the definition of prime number, that it is divisible 1 by itself, or in other words we can say that any number between 1 and the number itself, okay, that it will not going to divide it. Okay, so what we are checking out is whether, any number in between 1 to the number, okay, is it divisible or not. If it get divisible, then it is not a prime number. Okay, right? And if it doesn't get divisible, then we know that it is a prime number. So let us see for 2 is a prime number. For 3, yes, 2 and 3, sorry, between 1 and 3 it is 2, right? 2 doesn't, 3 doesn't divide by 2, that means 3 is a prime number. Okay, similarly if I write 7, 2, 3, 4, 5, okay, 6, okay, doesn't divide 7. Okay, so 7 is a prime number. But if you take 6, yes, it is easily divisible by 2. That is the reason why 6 is not a prime number. Okay, so this is one of the most simplest way in order to find whether a number is prime or not. Okay, so in the next session we'll discuss more on how we can, improvise this particular, the concept, because here we're trying to find out any number between, we don't want the number itself. If the number became very large, okay, so suppose say 1 billion, okay, then you have to do so much of, the loop will go execute. So, nearly, less, nearly 1 billion time. Okay, so in the next session we'll discuss more about how to improve this particular line of code. Okay.